Back by popular demand, I'm going to review the histology slides, but this time I'm going to go over epithelial tissue and all of the stratified epithelium that I didn't mention in the previous one. So just to recap, we're looking at two different types of visuals. We have an actual histology slide, and then we have a nice infographic version that's oversimplified. And so they're meant to represent one another, and I've specifically selected the stratified variety as well as the transitional variety. Now, just to review, the epithelial cells can be organized into layers. Epithelial cells including squamous, cuboidal, and columnar, and then the arrangement can be simple, meaning one layer, or stratified, meaning multiple layers. Starting with stratified squamous, meaning multiple layers of flat cells, these arrangements of cells are going to be optimized for dealing with abrasion and protecting against friction. Areas you might be familiar with where friction can occur, you're going to have your surface of your skin, oral cavity, anal cavity, vaginal cavity. Often it's going to be cavities as well as areas where there's interaction with the outside and harder substances. And so if you think about it, when you have the esophagus as represented here, this is part of the GI tract, and it's part of the earlier or upper GI tract where the food has yet to become digested into smaller pieces. So you're still dealing with larger substances that can cause friction. Now, to explain why it would be stratified layers of the thin cells, is because the thin cells don't have as much cytoplasm, they don't have a greater function compared to the cuboidal or columnar cells, and so these are essentially disposable cells, and so they would be perfect for losing, if you will, in times where you just need to forgo certain cells just to serve a minimal purpose, but in the long term, a very significant one at that. Now, as you see on this picture, I'll show you right over here, this is the basal region, and then as you go towards the surface, this becomes the apical region. And likewise over here, these are the basal regions of the squamous cells. You might notice that the nuclei are a little bit bigger, and then as you go towards the surface, they start to thin out because essentially they're kind of like getting squished up to the surface. And all the way up there, that's going to be the most apical region, and that's where the food particles would actually come in contact with that epithelial lining. Now, of the variety of stratified epithelial tissue, stratified squamous is the most popular of the stratified arrangements. Cuboidal and columnar are going to be less popular, but your professor may be wanting you to know an example of where to find them. It's not as common for stratified cuboidal or stratified columnar cells to have significantly multiple layers as we see here with the stratified squamous, but they may potentially have at least 2 layers, as you can see in the real histology slide. What we're looking at is a gland, and so you can imagine there is going to be a lumen in the middle of this gland, as you can see with that white space, and then the rest of these cells are going to be the cuboidal cells, and you can see there's a little bit of stacking of 2 thickness around that circle of the gland, and so that's where we would see the stratified cuboidal and the sweat glands. And then we have stratified columnar, common in the salivary duct, and so as you can see there is truly a stacking here of stratified with the nuclei above another nuclei, and this may or may not be confusing with the pseudo-stratified ciliated columnar epithelium, but as I just said, the way you can distinguish this slide with the other is the cilia. And so as you can see here, we do not see that wave-like sort of sea urchin-y apical region on the superficial end of these stratified columnar. And indeed, these are truly actually stratified, meaning they are actually layered. The pseudo-stratified are actually one layer. It's just that the way that they are arranged, they kind of blend into each other. And so the nuclei of the columnar cells actually kind of squeeze up amongst each other. So the last of the epithelial tissue is going to be the transitional epithelium, and the unique function for transitional is that its ability to transition its shapes. As you can see in the picture below, the layers of cells that occur are also showing different variety of shapes from basal to apical region. Likewise on the picture just below here, there's flatter looking cells that are going up to more plump cells, and it varies. This is not uncommon, and you will find this in the bladder because this transitional characteristic is ideal for areas where there's an expansion or a need to accommodate for volume in this space. And so, since the bladder is essentially a water bag that needs to expand and accommodate for urine, you will need specialized tissue that can serve that purpose. So in this slide, this is a special one because I'm combining not only the information from epithelial tissue, but also connective tissue proper. This is a combination slide of what you would see both different tissues coinciding to create an organ here. We are looking at a slide of a cross-section of skin. And so starting from the apical region here, so imagine this is like the surface of your skin right here, like right here. As we go down, so say if you got like a needle and you were getting punctured, you would be going deep into your skin. And so this is what's going on from the most superficial to the deeper layer into the connective tissue. And so as you can see here, there are layers here and this little squiggly lines, and there's a distinction from this darker pink to this lighter pink, and this arrangement of all these darker purple dots to indicate nuclei, and scattered dark purple dots that are throughout this sort of lighter blush pink. And if you know, I'm going to give you a second, maybe you can guess what type of tissue makes up right over here the dermis. The dermis is dense irregular connective tissue, and over here, since there's epithelial tissue backed by connective tissue, we know that this is multiple layers going to the very top, so multiple meaning stratified, and these are actually squamous cells, believe it or not. They may not look flat, but a visual indication of what squamous cells are is that they're not always necessarily skinny and flat, maybe if they're standing by themselves, but they're squished all together, and they do not uphold a very uniform box shape like cuboidal or a uniform longer shape like columnar. And so if you had a default, just default to squamous cells. And so what you can see here is that these are the same cells, and they produce more and more through mitosis to create multiple layers. What makes the cells that are on the basal region distinctly different going upwards is the fact that they've lost their nucleus. Now I'm going to save more on how to review integumentary system and a slide of the skin layers for another video, but I just wanted to show you, I think this would have been pretty cool to see how the stratified squamous epithelium of our skin interact with the dense irregular connective tissue histology that I have reviewed in a previous video. So hopefully that was useful to you, and hopefully you can gain a better understanding of how to identify and distinguish the key features of the cell, the membrane, the shape, and the layering, and being able to just confidently look at a slide and be able to cue in and say, I know what that is. And if you have any other questions, please comment, like, share, repost. It really helps get more students to see this. And I'm hoping to get more material out just so that everyone can have it in time for their next exam. All right, happy studying.